Welcome to Visualizing Dense Data. My name's Sasha Singh, and I'm a product consultant at Tableau. It's been a week packed full of content, and we had a big party last night, so I'm really proud of us all for making it to one last session today. Thanks for being here. Before I hop into content, I just wanted to take a second to introduce myself, tell you guys a little bit about me. I've been at Tableau for 4 years, and I've spent 3 years in this role. Oh. Is that working? There we go. Cool. We didn't miss anything. So in my day job, I act as a technical counterpart to our sales team. So you might know of my role as a pre-sales consultant or a sales engineer. And I support the entire central part of the United States. So I've gotten to go on a pretty great tour of the Midwest over the past couple years. I live in Austin, Texas, and outside of work, I like spending time outdoors. So camping, hiking, you name it. I'm actually going to the Grand Canyon as soon as the session's over pretty much, so I'm really excited about that. And I just love staying active and moving my body. It's a huge part of my life. Recently, I've become totally addicted to Orange Theory Fitness, if any of you have heard of it. It's a fitness workout with rowing, running, and strength training. And one of the reasons that I started it and got really into it is because it uses a data-driven approach to fitness. So you wear a fitness tracker, and they monitor your heart rate and give you a lot of data on how you're performing. And I was even able to make a dashboard out of it in Tableau. So that's something that I'm really interested in. So to kick things off, I just wanted to get a pulse of everyone in the room. How many of you have made a visualization that looks something like this? Yeah, a lot of you. I see it's probably why you're in this session today. I like to call this the big blue blob. And it may look like a scatter plot, but when I look at the big blue blob, what I see is a density monster. Really what this is a dense, ill-defined, difficult to make sense of data set, right? And we're going to be spending a lot of time with the density monster today, so I wanted to make sure that he got his intro as well. By the end of this session, my goal is for us all to have a few tools on how we can move from something like the big blue blob to something that's easier to make sense of. So we're going to be going over techniques in Tableau to help us all fight the big blue blobs in our lives. To give you an analogy, Tableau gives us a toolbox with a bunch of different tools to analyze data in a visual way, right? So thinking of a toolbox, you might have a flathead or a Phillips head screwdriver. In Tableau, we have so many different tools as well that are available to us. So my goal is for us to all walk away understanding which tool to use for which kind of data and to be able to make sense of dense data a little bit better. Just to go over our agenda, we're going to be spending the first portion of the session in working with the big blue blob. So we'll talk about some native functionality, look at how we can leverage the marks card and statistics to make sense of blobs of data. We'll be looking at binning and some distribution charts. I'm going to show you guys a really cool example of a loop tip and a zoomable chart. And then in the second half of the session, we're going to switch gears a little bit and look at an example more focused on mapping. And so we're going to be looking at a data set from, it's very relevant to Las Vegas. It's Las Vegas building permits, and we'll be talking about symbolization, aggregating geographic data and binning in the way that we will be with the big blue blob. We'll touch on spatial joins and also hexbinning and hex maps. So as far as the content goes, I wanted to start off with this quote by Edward Tufte from his book, Envisioning Information. If you don't know him, he's sort of like a god in the data visualization space. And what this quote is really highlighting is some of the problems that we run into when we're visualizing dense data. So we want to make sure that we're interpreting data in the best and most efficient way for the analysis and the questions that we're wanting to ask, right? So we might wonder, is the chart type appropriate for the question? Does the granularity make sense? Is it misleading? There's a lot of factors to consider stacked on top of the data already being dense. And I wanted to include this quote for a couple of reasons. I mean, I feel like it's relevant to the topic today, but I also have been, for years, presented at TC a few times, been wanting to find a reason to use the quote slide template that our marketing team puts together. And this year, I managed to work into both of my sessions, so I'm really proud of myself. It also reminded me of the first dashboard that I ever published on Tableau Public. So this was the dashboard, and it was aptly titled UFO Sightings in the United States. This is real data. There's an agency that collects this information, and I was surprised to see that this data set showed up in the keynote this week too. I think it was during Devs on Stage. But I had my 3 standard vises on my dashboard: my map, my bar, and my line chart. And the map is really where my density problem was taking place. It was my big orange blob. Oh, zoom in here. Sorry, guys, I don't know what's going on with my PowerPoint. Give me 1 second. Let's see. So I'll just show you guys this way. But what I wanted to highlight in this dashboard is the map, because that's really where my density problem was taking place. And because there were so many UFO sightings in the data set, it was really difficult to make sense of any of this data. My clever solution to this was I thought I'd add a legend and use some guided analytics. And yeah. No, I'm just wanting to show that, but my slides, I don't know what's going on with it. Yeah.
What you see here is going to be showing up on the screen too.
Mm-hmm. Okay. All right, that's fine. Really the point behind this story is that what I was facing with the big blue blob and what I thought I could get around with the legend is a classic case of overplotting. And so that's what I ran into with my map. But this is what it looked like even when I added that interactive legend. So I like to think that I've learned a few things over the past 3 years working at Tableau and working with Tableau Desktop, and how we can use Tableau and the tools that are available to us to make sense of the big blobs of data that we run into, whether it's a scatter plot or a map. So just to switch gears, let's hop into Tableau Desktop and start working with our big blue blob of data. Right. So this is the data set that we're going to be spending most of the session with today. And this is that big blue blob, but we're just looking at it as a crosstab here. So we have our observation ID, which is just our row identifier, and then we have our X and Y values. And so the context of this data set doesn't really matter too much. What's really important is just that we have a lot of data. It's dense, right? And then we have these observations that we're tracking. The Y value runs from about 0 to 12.5, and then for X we have about -1 to 11. So I want to start by just talking about how we can use some of the native functionality, like the marks card and statistics, to start to make sense of this. So in our first sheet, let's just consider how far we can get with just the marks card and summary statistics. I'll start by bringing out my data, and we only have 3 fields. So it's that sum of X, sum of Y, and then the observation ID, which I'm going to put on detail. And Tableau's warning me here. It says, are you sure you want to put this much data on a scatter plot? And I'm going to say, yeah, let's see what happens. Switch that around there. And now we see our familiar friend, our big blue blob of data. In the marks card, we can start to play around with some of our visual attributes, right? So I can dial the size down just to start and see what happens there. And really all that does is gives me a big blue blob with a fuzzy edge around it. But what's interesting in here is that I can see that my data is pretty densely packed in the center. So that's something that I can start to glean from playing around with the size. I'll dial that back up. Now let's look at what happens when I dial the opacity down. So again, I'm seeing a lot of what we saw with dialing the size down, but I can start to see where some marks are stacked on top of each other, right? So where we have these darker areas in the fuzzy edge, I can see that maybe there's a cluster of marks, and that might be an interesting observation to make as well. The last thing we can do in the marks card is change the mark type itself to density. So if any of you are using an older version of Tableau Desktop, I think this was released in the past year or so, but the density mark type allows us to change our scatter plot into a density chart, right? And so I can start to look at this in a slightly different way. I could play around with color if I wanted to see the density color palettes that come along with this mark type, right? We can sort of toggle through those. And I'm seeing a lot of what I've already started to observe with the marks card, which is that I have a really densely packed center and then a fuzzier edge around my scatter plot here. So I'll change this back to a circle. The other thing I've done on this worksheet is I've surfaced our summary card. So the summary card is something that's native to Tableau Desktop, and if you've never surfaced it, you can do that in the worksheet menu at the top. So that'll just be the show summary option here. And what it does is it outlines some standard measurements, things like average, sum, max, min, median. But then there's also some more abstract concepts in here like quartiles and skewness and kurtosis, which we'll get into in a second. As we're looking at this, there's a couple things that we've maybe already noticed or aren't terribly surprising. So we've got our min and our max values, which we already saw in the initial dashboard when we were looking at the data. I can also see under the X value that I have a median of 5, and then I have an average of 5. And what that suggests to me is that that's a fairly normal distribution. With the Y value, I'm seeing that the average is 1, and we've got a median of 0.7. And so that suggests that there's a little bit of a skew, and we'll get into what that means in a second. So just to talk a little bit about those concepts. With a normal distribution, some of you might be familiar with this concept from a high school math class, but just to level set on what some of these concepts mean, when we're working with measurements like averages and standard deviations, when we're thinking about a normal distribution. And one standard deviation in the example that we're seeing here would be the distance between the average, so that's at 0 here, going out on each side, right? So we see a single standard deviation here is 34.1%, and then 13.6, and so on. And as we go further out, more of the data is encompassed within one of those deviations. Kurtosis describes the shape of our curve. And so that essentially is telling us whether the curve is skinny, or if it's wider, or if it's normal, which we saw with our X value. And then finally, skewness describes a lean either to the left or the right. So positive in one direction, negative in the other, and this is what we were seeing with our Y value in the summary card. So one thing we could do with our big blue blob and the native statistics that Tableau gives us is put them into a dashboard, right? And we can start to see with the knowledge that we have in this accompanying dashboard, we can start to make sense of some of this. I can tell that I have a normal distribution. I can see that with Y I have a little bit of a skew, right? So those are some initial questions that we can answer. But the next thing I want to ask is how can we take this and put it into a format that's a little bit more digestible and more visual? Because as Tableau nerds, that's how we want to visualize our data rather than in the crosstab or text format. Before I move on, I'm just going to put a couple fields here on detail, which we'll need later. All right. So next, I want to get into talking about binning and distribution charts. So when we're binning, we're essentially taking many data points and then we're aggregating them up to a higher aggregation, right? And so you can think of a bin as essentially buckets that we're going to use to bucket our data into. So if we had values ranging from, say, 0 to 100, and our bins were sized with a range of 10, then anything from 0 to 10 would go in bin 1. Anything from 11 to 20 would go in bin 2. And many of you may already know this, but in Tableau, you can create bins natively. So all you have to do is go over to a mark, and then in the menu, you'll see the create option. And I can select create, and I can create a bin. And so that's a native way to do it, right? Tableau will let you define the bin. You can define the size, or just go with the default option, and you can go ahead and name it as well. But for the sake of the session today, and you'll see why I chose to do this later on a little bit, I went ahead and created custom bins. And so it's a simple calculation, but all it's doing is it's looking at the X value, and then it's multiplying or scaling it up by 10, and then turning it into an integer. And then we're dividing that back down and truncating the data at an arbitrary value. And here I've used 10 because I want to round that value to 0.1. I see some of you guys taking pictures. Of course, feel free to, but all of this content will be provided in. There will be a recording of this after TC2. So if you want to just let the knowledge wash over you for now, just wanted to make everyone aware of that. But with our bins, I've done the same thing for Y, right? So we've just created bins with a value of 10 being the range. And now I can start to create our first distribution plot, which is going to be a histogram or a frequency polygon. So I'm going to go ahead and take my bin of X and put it on columns. And I'm going to go ahead and change that to continuous field. And then I'll also go ahead and bring out my number of records, and I'll put that on rows. And now we can see what we were seeing in that statistics dashboard, right? These are our X values that we're looking at, and we see that very normal distribution start to take shape. I'm going to change the size here to fixed width of 0.1, just so we don't have any of these bars stacked on top of each other. And I'll also go ahead and reverse my axis. You guys will see why in a bit. And I'll just hide these headers as well. The next thing I'm going to build out is a strip plot. And again, we're going to be looking at X first. So I'll go ahead and bring out my X value and just put that on columns. And then I'm going to go ahead and take observation ID and put it on detail. So now we have that general shape of our strip plot. But what this is really doing is essentially adding a stripe to the viz for every mark that we have, every observation that we have. And so we can see each of these outlined as we hover over. And like we were seeing in the big blue blob, we have a densely packed center. And so that's, again, suggesting that normal distribution that we've been talking about. How many of you use the Analytics tab at all in Tableau Desktop? Quite a few of you? OK, so it seems like that you guys are pretty familiar with it. The box plot is one drag and drop option under the custom section of the tab. And I'm going to go ahead and drag this out onto the view. So a box plot goes out one standard deviation from the median in each direction, right? So as I hover over this, I can start to gather a little bit more information about what the view that I'm looking at. And I'm starting to see some of the same information that I was seeing in my summary statistics card, but in a more visual way. So I can see that median of 5. I can see my normal distribution. And I can also start to gather some information about those standard deviations that we were seeing in that summary card, but a little bit more visual in nature, right? If I wanted to just do some outlier analysis, I can come into the box plot and start to customize it. Maybe I just want to hide the underlying marks and focus on what's outside of our box plot. So there's a few ways we can sort of customize and play around with this. I'm going to go ahead and bring my bins out onto detail, hide my header. And there we've got our two frequency polygons that we're going to build with X. So I'm going to go ahead and do the same thing for Y. I'm going to bring out my bin of Y. I'll change it to continuous. I'll bring number of records out. I'm going to change my size to fixed width of 1. And I'll go ahead and hide my headers. But you can start to see that the Y values are a lot different than what we were seeing with the X, right? So as we saw in the summary statistics, we had a normal distribution for our X values. Whereas with Y, we can see some skew taking shape here. So I'll do the same thing. Build out a strip plot with Y as well. Just going to go ahead and bring out a Y value. Observation ID onto detail. And again, we're seeing the same thing. Instead of having a densely packed center, we have a densely packed sort of skew to the left here. Go ahead and drag out a box plot as well. Hide that header. And bring out my bins onto detail. And so you guys probably guessed that this is all these different charts that we've created are driving towards something. What they're really driving towards is this dashboard that I put together that straps each separate piece of analysis that we just did, right? We took that summary card, we put it into a more visual format, and now we've put it all together into a dashboard. And together with some hover actions, we can start to drill down into our big blue blob and understand how that relates, whether with the x value or the y value, right? Where does that fall on the distribution? Does that fall within a single standard deviation? So we can start to answer some more complex questions with this just by hovering over our view and building out a few simple pieces of analysis, rather than what we started with, right, which was just our big blue blob with some numbers that may or may not have made sense to us at the beginning. I wanted to throw in this heat map that's created with the bins that we're using as well, just to show you guys kind of another approach to building out a heat map. And before we had that density mark type, which was only introduced in the past couple of dot releases, this was the approach to building out something like that. So just another interesting way to look at some of this information, but we're seeing that same densely packed center here. So the next thing I want to switch gears and look at is the loop tip. So for anyone who isn't familiar with what a loop tip is, it's like a jeweler's loop, right? So they use a little magnifying glass to look closely at jewels and that kind of thing. And so a loop tip is sort of what we're going to be simulating with the combination of our density monster along with a viz and tooltip. Have any of you guys used viz and tooltip? I think that came out in 10.5, so it's been about a year now. Yeah, so it's a great way to add a really interactive and intuitive sort of filtering into your visualization, right? Because as an end user, it's really sort of our nature to be like, okay, what's going on there? We hover over a mark. And then to have a drill down version of that at our fingertips is really cool. So to build out the loop tip, what we're going to be doing is we're just essentially going to be creating another big blue blob. And so I'm going to bring my x and y values out. I'll bring out observation ID, turn that around. Cool, right? So then we can go back into our original view, and when we hover over our marks, we're kind of seeing what we're driving towards. But as I hover over these marks, I can see the values that fall around it within our bins, but they're all scrunched up in the top right-hand corner. And so if we're looking at some of these outliers that only have one mark within their bin, it's easy to make sense of, but when we get into our densely packed center, this gets a little bit more confusing. So how do we get around this? One thing we can do is deselect include 0, which is just an option in our edit axis menu here. And that's going to give our axes a little bit more flexibility to move around and sort of respond as we hover over these marks. And so now we're sort of driving towards our final loop tip here. But the last step that I want to take is when we hover over some of these marks sort of on the outside and the fuzzy edge of our big blue blob, rather than being placed spatially, where they lie within that bin and that radius that surrounds the specific mark that we're hovering over, they're being centered. And so what we can do to get around that is bring in some reference lines. And I've already created those calculations, so I'll go ahead and drag them out and show you the difference here. Right? When I hover over one of those marks, rather than being centered, we're seeing the entire range. So we're essentially locking in a range for our bin, and then spatially we can see exactly where within that range the specific mark is landing, which is a little bit more intuitive, right? A little less misleading. These x lower bound, x upper bound, the way that I got them onto the view is just by using reference lines. So how many of you were aware that when you bring out a reference line, you can have it reference any field in your data set as long as it's on detail? Has anyone done that before? A few of you? Yeah, so it's a great way to bring additional context into your view without actually having to put it on columns or rows. We'll take this guy off. But the calculations themselves are pretty easy. They're nothing too tricky. Here I've just taken the min of my bin x, right? And that is being used as my x lower boundary. So I'm asking Tableau, what's the minimum value that the bin could be? And that's what this calculation is going to return. And then the x lower bound is the exact same thing. And then for the upper boundary for x and y, I have just used that initial calculation, essentially nested it in here, and then I've just added 0.1, which is the width of our bin. right? And so that's going to give us the upper boundary. We're looking at a min and a max here, essentially. And then when we go back to our density monster, we can see all this sort of strapped together and take place. And those reference lines are really coming into play when we look at some of these outliers to spatially understand where the mark's landing. So that's another way we can start to make sense of some of this dense data. I wanted to show you guys one more example of zoomable charts. And, oh, did you have a question? Yes, thank you for bringing that up. I meant to mention that, but it slipped my mind. So in the tooltip, when you insert a visualization, by default, it's going to do exactly what you described. It's going to filter just over what you're hovering. But you can change that. And so here I've specified, you can see in the tooltip, as my filter, I've specified bin X and bin Y. And so I've defined that a little bit further. So it's a simple thing to do, but you can sort of change the generic confines of that. Cool. So yeah, the next example I wanted to show you guys is another example of a zoomable chart that's been floating around in the community. And it is a little bit more complex, but it's really cool, and it builds off of some of the concepts that we just saw with the loop tip. And so while generally I probably wouldn't include it in an intermediate session, I think you guys can handle it. And like I said, you're going to have the content afterwards if you want to take a look at how some of it was built. But I'll walk through some of the calculations. And the foundation of it is using set actions. So that's something that we released earlier this year. Any of you guys using set actions? I feel like I'm still figuring them out too. There's so much you can do with them, right? And there's a great blog post written by one of our product managers at Tableau named Bethany Lyons. You might have heard of her. She has written this blog post on her website that goes through both sort of conceptually what set actions do, and then there's also a lot of practical examples. So if there's something you're curious to explore, I definitely recommend it. But just to give you a high level on what they're doing, right? Sets are Boolean in nature, so the result is either going to be true or false, or 1 or 0. And with a set versus a filter, when we're filtering data, it's either completely removed from the view or it's in the view. But with a set, you can sort of dynamically move things in the set or out of the set. And you can also see simultaneously what's falling within the set versus what's falling outside of the set. Right? So they're a little bit different in that way. So with this other zooming example, we're really just starting with our same big blue blob. And there's 4 calculations that we need to create, and then of course we need to create our set, since this is founded on a set action. And so the set itself is really easy, really simple to make. All I've done is created a set on my observation ID, since that's the dimension that we're considering here. And by default, I've only selected one observation ID. And so it's pretty arbitrary which one you select. I think I selected the last one initially, but the reason that we do that is because we're only going to be considering one observation ID at a time. And then we create these 4 calculations. And so this first calculation is, at a high level, what it's doing is it's telling us what the highlighted observation is for zooming. When we zoom over our scatter plot, we're focusing on one specific observation ID, right? And that's what this calculation is specifying. So the if and only if function here is checking if the observation ID that we've selected in our set matches the observation ID that we're hovering over. And then if it does, a true is returned, and if it doesn't, then a false is returned. And this first calculation is sort of the foundation here, because we're going to nest it into our other calculations here. So in this second calculation, and this is going to be identical for x and y, just one's considering x, one is considering y. But this second calculation is telling us the value for x for the highlighted observation. And so our first calculation, which returned either a true or a null, is nested in this calculation. And it's going to return the x value of the mark we're hovering over, if the first calculation was true. And if it wasn't true, right, so if it was a null, then it's going to continue to just return a null. Y is going to be the same thing, just with the y value instead of x. And then we've got this final calculation. And the final calculation here is going to tell us, again, which observations we're wanting to include on the zoomed view, right? So there's kind of two pieces to consider here. Which mark are we hovering over on the scatter plot, and then which marks are going to show up in the zoomed view? In the same way we saw with the loop tip, we're wanting to see a number of marks that sort of fall within the same bin range. And the result of this calculation is going to result in either an include or an exclude. So sort of Boolean, it's resulting in a string field or a string value. These parameters that you see here, the zoom y amount and zoom x amount, so those are the purple that we see in the calculation, are essentially functioning as variables that are going to define the axis ticks, right? So when you think of a scatter plot, each axis has a series of ticks, and you can define where those occur. And so here I've used parameters to set those at 0.05, but I could make it 1 or 2 or 3, right? Just depending on how zoomed in or zoomed out I wanted to be. And then this calculation is going to subtract the actual x or y value of the mark that we're hovering over by the result of the last calculation, if the result of the last calculation is less than or equal to the boundary set by our parameters. And the result of that is that it's going to show us, similar to our loop tip with the bins, it's going to show us within the range that we've defined what other marks are surrounding the mark that we've hovered over. And so to put this all together, similar to the loop tip, you want to create a second big blue blob, but here I've already sort of put it all together. We're using our same max and min upper bounds and lower bounds to define the range of our bin, and then we've got the marks selected here. To put it all together in a dashboard, this is sort of the final result. We've got our big blue blob, but as I hover over marks, I'm going to see a similar effect to what we saw with the loop tip. And the way that this is all being triggered, right, we had those calculations, we had the set action, but I've created we had the set, but I've created a set action. And so the set action is going to exist within a dashboard, similar to filter actions. I'm sure you guys have all used those. And what we've told Tableau here is that we're going to run the set action on hover. So when I hover over a mark on my big blue blob, something's going to happen. My action will be triggered. My source sheet is my initial big blue blob, and then my target set is just the set that I created of my observations. So if, based on the logic in our calculations, the mark that I'm hovering over meets the requirements set by our set action, then those marks are going to appear in the zoom chart. So that's a slightly more advanced, or maybe quite a bit more advanced, but something that's building off the loop tip, right? Something that's a little bit more simpler. How can we take it to the next level? All right. So now we're going to go ahead and switch gears a little bit, but in some ways not at all, because we're still going to be looking at dense data that we are going to be aggregating up to a higher level to try and make sense of blobs of data, right? And this is where we're going to switch gears and look at Las Vegas building permits. And so I don't know about you guys, but I haven't been outside in days. I feel like these hotels are connected through some sort of tunnel system or something like that. So we're going to look at some data about the outside world, just remind ourselves that there is a world outside of Vegas. So this data set is just over 200,000 rows, so it's also quite dense, similar to our big blue blob. And when we put it on a map, we still have a big blue blob, but it's a slightly different big blue blob. The data set itself is looking at building permits from Las Vegas, right? So every casino, every hotel, every home even has to have a permit that is applied for. Just like we did with the big blue blob, we can explore what we can do with just tinkering around with the marks card. And in the world of mapping, we would call this symbolization. So that's going to be how we can toy with pre-attentive attributes to understand a little bit about this map, right? So we can dial the size down. And with a map, dialing the size down can tell us a lot. So for example, if I zoom in to this left side of the Las Vegas area here, I can kind of see that these marks are following the general path of roads, right? So this is a neighborhood, most likely. You can kind of see cul-de-sacs, and you can see where houses are sort of lining up like little boxes. If I were to zoom into this area down here, any guesses on what that is? It's a strip of marks. It's a strip. So that in this area, right, we can see that unlike what we see in the bottom right, where it's sort of looking more like a neighborhood in the way that we're used to, we've got this strip here, which is following the path of a strip. And so it's interesting how we can start to make sense of this as we lower down the size. We can start to glean a little bit of information of what this map is actually telling us. We can also, I'll dial the size back up here, but same as we did before, we can lower the opacity. And this is really densely packed in the center, but we can see some of those brighter blue marks on the outsides, the outliers. And as we zoom into those, we can see that those are sort of a cluster, right? So there might be, even though they're outside of the general Las Vegas area, if there's a sort of darker spot, that might mean that there was many building permits applied for in that area. Just like we did with our big blue blob, I want to bring some color in here as well and see what that does. And so I'm going to go ahead and bring out application type. And just put that on color. And at first, this kind of looks like what I saw with my UFO dashboard in my slides earlier, right? It's really hard to make sense of, but we can always pare down what we're looking at. And one of the big problems with that UFO dashboard is that even though I had put color on there, it was still difficult to make sense of because I'd grouped a lot of those values in the legends, a lot of those dimensions together. Whereas in this data set, there's some higher level data that we can work with. So if I click on commercial, for example, I can start to make sense of this a little bit further. I can see some of these commercial building permits are running across a major highway, which makes sense. We also see a big cluster of those marks over in the bottom right in the strip. With residential, we can see what we saw earlier, right? It's sort of the outskirts of the Las Vegas area. We have our neighborhoods. And then pools and spas are just everywhere, because I guess it's so hot here. Now let's move into, just like we did earlier, how we can take that map and start to aggregate some of it, bin it together, but more in a more spatial situation. So I've created a couple of calculations here that we're going to be working with. And these are using the round function. I'm actually going to go ahead and open up the calculation dictionary here. So the function that we're using here is called round. And we're using it in conjunction with the latitude field. And we're going to create square bins. What the round function does is it rounds our value that we've specified, our field, to the number of decimal places that we specified. And so here I'm rounding latitude to 1. The example in the dictionary here, I think, really helps clarify what this function's really doing, right? We've got 3.1415. We've specified its decimal place at 1, and so this is going to round. The result will be 3.1. And so what that does with the latitude and longitude when we're thinking of mapping is it's going to make our lats and longs less specific, right? And that's going to allow us to zoom out a little bit and create bins in the same way we did earlier with the big blue blob. So I've done the same thing with lat and long. The calculations are identical. And I can double click on these to build out my map. So I've just got this one mark out so far, but I'll go ahead and bring out another calculation I created here. It's nothing complicated, but I just took the lats and longs that I just created with the round function, and I just concatenated them together and made them strings. And so if we look at what the result of that looks like, right, there's not a lot of values left. There's only 19 marks rather than however many we started with in the original map. And when I use that field to break this out on detail, this is starting to take shape a little bit. Really, the only other thing we need to do here is change the mark type to a square. I can dial this up a little bit, maybe bring out some color, bring out my number of applications out. Maybe I'll change the color palette here, something that's a little bit more Vegas-y. And then we've got our square bins, right? So we can start to see where clusters of these marks are. And so we've got a lot of building permits over here in this specific zip code, right? We have over 68,000, whereas in some of the outskirts of Vegas, there's not quite as many. We can also break this out with application type if we wanted to put that on. Columns there, I can Just dial the size down a little bit. And so this is sort of building off of what we were doing with our big blue blob, same concept, but applied in a spatial setting. For this last section here, I want to talk about hex maps and hex binning. In the past, in order to create a hex map, you either needed to join in a file, so you guys might have seen they're really popular on Tableau Public, or you needed to write some pretty complex calculations using our hex bin functions. So I'm still going to show you some of what you can do with that, but I also wanted to talk a little bit about spatial joins, because those were introduced, I think, over the past year. And just to talk a little bit about what spatial joins do, really the magic behind them is that they use a new join predicate, right? We're used to seeing equals or greater than or less than or something like that. But with a spatial join, we're using a predicate called intersects. And so intersects is going to match the location of our points from a geographic data or spatial file to polygons from another table. In the context of what we're doing here, in our Las Vegas building permits data, we have a data set that has latitudes and longitudes, right? But that's pretty granular, and we want to instead place those lots and longs into the hexagon polygons that we're going to be rolling this up to. And so really what we need to do in order to do that is, let's hop into the data source tab here, show you guys this. So I've joined together my building permits data that we're already using along with a spatial file. If any of you aren't familiar with something like ArcGIS or QGIS, QGIS is free. It's something that you can easily use to create a spatial file. So especially if you're, say, if you lived in Las Vegas and you're consistently mapping the same area, it might be worth it to create that spatial file so that you can use it consistently. Because what you're going to be able to do with a spatial file, it comes with a field called geometry. And geometry is what Tableau uses to place our marks or our polygons onto a map. The intersects is going to see where do those lots and longs fall into the geometry of the polygons, right? Which polygon do they fall into? And in order to join these together, I've actually used a join calculation. The make point function is what I used here, and the make point function essentially takes those lots and longs and turns them into a geometry as well. So once we've joined the spatial file in, we can start to build out our viz here. I just need to bring out our latitude and longitude, and then I'll bring out my ID onto detail, and I'll also go ahead and bring out geometry onto detail. And as soon as I bring that geometry out, right, I can see each of those little hex bins that were in my spatial file take shape. But if I were to take ID off, when I hover over this, you see how that's a little different, right? I'm seeing the entire Las Vegas area as if it's one mark. And we can also see that down here at the bottom. I've only got one mark. But when I bring ID onto detail, I'm giving Tableau the context of where do those lots and longs fall into these specific hexagons? Where do they intersect? And we're also going to go ahead and leave the shape type on automatic because that context of the hex bin is already in our shapefile. From there, we can do something similar to what we did with our square bins. Right? We can put number of records on color. Maybe I want to change this to a different color palette here, slightly different view. And since this is a little bit more granular, right, there's different insights to be gleaned here. Like I can see that there's specific hex bins in the bottom right that are a lot darker than what we saw with the square bins, which makes a little bit more sense to me considering the strip is in this area. The last thing I wanted to show you guys, as far as hex maps go, is, let's just say that you don't have QGIS, you can't find a shapefile for the area that you're wanting to hex bin. There are those built-in calculations that are natively in Tableau. And instead of rounding the function, these essentially find the centroid of the lat and long, and then in that way place them in the center of those hex bins. And so these are natively in Tableau. We have an hex bin Y, a hex bin X. And those are what I've used to actually create my maps. You'll see that I have no lats and longs on the columns and rows. I just have those two calculations. And I've used hexbin ID, which is a calculation that I created. Similar to what we saw earlier with the square bins, I've just concatenated the result of hexbin X and hexbin Y as a string value together, and those are what are used to break this out. One way that you can sort of expand on this and make it a little bit more interactive for your end users is change how this is being rounded. And so you'll see in this initial, not that guy, in this initial function, I'm multiplying my latitude and longitude by 150, right? And that's what's giving us our hexbin, sort of aggregating those values up. But if I wanted to make this more dynamic, you can also create scaled versions of this. And so using a parameter, similar to what we saw with our zoomable chart, right? Being able to change the sort of parameters of what we're seeing in the visualization for the axes, you can add in the hex scalar parameter, which here it's just a simple parameter. The data type is float. I've made the current value 150, which is what we started with originally, min and max of 300, but it's just a number. And as I dial this up, right, if I wanted to dial this value up to, say, 300 or 224, this is going to get either more or less granular. The other thing to keep in mind when you're using the custom calculations is that you do want to change the shape, because with the shapefile, you have natively those hex bins, polygons inherent to those. But here, I've just brought in a PNG that I found somewhere on Google and used that to define the shape that we're seeing here. But you could always use something like a circle or a square, too. So with that, that brings me to the end of the content. Thanks so much, everyone, for sticking around for one final session today. Hopefully you guys all had a couple of takeaways here on how you can start to make sense of your dense data, whether it's in something like a scatter plot or even spatially with maps. If you have a second, please complete the session survey on the app. It means a lot to us if you can do that. We always appreciate the feedback, and safe travels home.